You know that feeling, right? That moment when you finally stop wrestling with your code editor, battling syntax and configuration, and suddenly you're just shipping again. You're flowing, building, creating. That elusive state of true developer productivity. Well, that's the powerful promise we're diving into today. We're taking a deep, deep look at OpenAI Codex in 2025. But here's the crucial distinction. We're not just examining it as another tool or, a fancy plugin. The sources we've got in front of us paint a picture of it as a complete integrated system, really designed to fundamentally streamline your entire development workflow. Think of it maybe as a coding agent, something that can seamlessly read your entire repository, execute focused edits, run commands, and even open pull requests on your behalf.
Yeah, exactly. And our mission in this deep dive is to truly unpack what Codex represents, sort of moving beyond those surface level descriptions like model or plugin. We want to reveal how it's designed to integrate across your entire development environment. And we're talking from your terminal straight into your IDE and all the way up to the cloud. We really want to give you a shortcut to being well informed about this pretty powerful new technology, focusing on the nuggets of knowledge, maybe some surprising facts that will help you understand its practical applications and maybe more importantly, how you can leverage it today to, elevate your own work.
The sources repeatedly describe it with this really compelling phrase, one brain that follows you, not three different tools you have to juggle.
Mm.
That idea of a single, consistent intelligence,
Mm-hmm.
it feels transformative. So what does this one brain actually entail? What's the profound implication of that kind of architecture for you, the developer?
Well, what's truly revolutionary here isn't just what it does, but how it does it. It's an intelligent system. It reads, edits, runs, and reasons about your code across all your different work surfaces. The profound insight, I think, is that this isn't just another assistant, it's more like an intelligent, omnipresent partner. It's deeply context-aware. It understands your project structure, maintains state as you move between local development and cloud tasks. So when people ask, what is OpenAI Codex, they're often trying to pin it down, right? Is it a model, a plugin, a cloud agent? The answer, actually, is it's kind of all three, seamlessly connected and unified by your OpenAI account. This integrated brain fundamentally changes how you interact with your code base. It allows for, well, unprecedented efficiency and consistency because your AI isn't starting fresh with every new task or environment switch.
Right, that seamless context transfer is key. Okay, so this sounds like something pretty much every developer is going to want to try. How do you actually get your hands on this one brain then? And what does it cost? Are we talking a whole new subscription or is it integrated somehow?
You'll find OpenAI Codex integrated into the paid ChatGPT plans. So Plus Pro, Team, Edu, and Enterprise. If you're already on one of those, you likely have access or can get it easily. Your specific allowance for tasks, both local and cloud, it sort of depends on your plan level and also the complexity of the work you're doing. So for instance, a small focused script edit uses less of your capacity than, say, a big multi-file refactor across several modules. It's designed to scale with what you need.
Okay, that scaling makes sense. But, hitting those caps during a really intense local coding session,
Yeah.
that could feel like hitting a wall, right? Breaks that flow you just described.
Yeah.
How does that API key billing option you mentioned really prevent disruption? How does it maintain momentum, especially if you're deep in the zone?
Yeah, that's precisely the point, and it's a critical design choice, I think. If you happen to outgrow your plan's cadence during, a particularly intense coding sprint, a key detail is that you can seamlessly switch your local tools over to API key billing. Think of it like an overflow valve. It ensures your momentum isn't broken. You can just keep pushing forward without a hiccup. Maybe you're deep in that refactor that suddenly demands more context or more intense reasoning than your standard plan allows. It's like a fluid transition from a metered subscription to a pay-as-you-go for that burst capacity right there on your local machine. It keeps you productive and in the flow.
Got it, an overflow valve. Okay, so once you're set up with access, how do you actually kick things off? What are the entry points? How do you start working with this assistant?
Well, you've got three primary ways to begin, and they're specifically designed to play nicely together, forming that one-brain experience we talked about. First up, there's the cloud agent. You can create a new GitHub repo or connect an existing one right from the web interface. From there, you can launch tasks, review detailed diffs, iterate on the changes, and open pull requests. Pretty straightforward. Second, the IDE extension. This is where it lives right inside your, daily coding environment. You install the Codex IDE extension. It works with popular ones like VS Code, Cursor, Windsurf, VS Code Insider, Sign-In, and boom, you're working directly against your open files. And third, for the power users, or maybe just terminal fans, there's the CLI, the command line interface. Install the OpenAI Codex CLI, authenticate, and you can operate within your repository directly from your terminal. Fast and direct.
That triad of access points makes a lot of sense, yeah. Covers different workflows. Can you give us a quick, maybe catchable example of a first task, something simple to illustrate that baseline rhythm you mentioned?
Absolutely. Let's imagine you need to add a feature flag to a small service you're working on. Your first task could be as simple as asking Codex through any of those interfaces, something like add a feature flag called experimental feature enabled to the user service and default it to false. It'll then scan your project, propose a clear plan of action, carefully edit the relevant guarded code paths. It'll even run any existing tests to ensure nothing's broken, and then present you with a diff of its proposed changes. You then just look it over, accept, or maybe iterate further if you want tweaks, and finally open a PR. This kind of establishes that core rhythm for daily use. It's really useful for setting expectations and, honestly, building trust with the tool.
That comprehensive first pass scanning, planning, editing, testing, diffing. Yeah, that's a truly powerful start. Now let's hone in on that command line interface, the CLI. The sources call it the fast lane. What makes the CLI experience so potent for developers, especially those of us who, live in the terminal?
Right, the CLI is where that one brain really flexes its muscles for speed and precision. It reads files, edits them with incredible accuracy, and runs commands right inside your repository. It's absolutely ideal for tasks like scaffolding new components, executing large-scale refactors, or running scripted operations that need direct interaction with your file system. Installation is super straightforward too, usually via NPM or Homebrew on macOS and Linux. For Windows users, we strongly recommend using WSL, that's the Windows subsystem for Linux. You just get the best experience there. Provides that native Unix-like environment Codex really thrives in.
That's good advice for cross-platform consistency. Can you give us some specific examples? Like, what might someone actually type into the CLI to get work done?
Sure. You could say something like Codex refactor srcoth_token.ts to isolate JWT signing and verification into separate utility functions. Ensure all existing tests remain green. See how specific that is. And it includes that validation step about the tests, or maybe for a new feature, Codex. Add getthealth to the FastAPI app, return status.ok, and wire it to the main router in main.po. It understands the context of your project structure quite well, which makes these highly focused requests possible without needing to manually spell out every single file path. It basically knows your project is a map, and it understands how to navigate it effectively.
That sounds incredibly powerful for quick, precise changes. But okay, with that power,
Yep.
the critical question immediately comes up for anyone running an agent on their machine. Control. How much control do you actually have over what it does in your local file system? Safety first, right?
Absolutely, and this raises an essential point about safety and control. It's clear OpenAI prioritized this in the design. Codex offers these crucial approval modes to give you that granular control. In chat mode, it reads context and drafts changes, but you explicitly review and apply them. Think of it like an intelligent pair programmer making suggestions. Then there's agent mode. Here it reads, edits, and runs commands directly in your working directory, but, and this is key, it still requires approvals for sensitive steps. Things like writing to disk or executing commands that could have side effects. Finally, for those who really trust it or maybe are in a very controlled environment like a feature branch, there's agent, full access. This skips many prompts, obviously use this one wisely. Ideally within a feature branch where you can easily revert if anything unexpected happens. These modes are critical because they balance that speed versus safety equation. They let you choose your level of delegation. Agent full access, for instance, it isn't just about convenience. It's about trusting the agent enough in a controlled space to accelerate highly repetitive or well-defined tasks. It frees up your mental energy. It's really a spectrum of trust and delegation, letting you decide what's appropriate.
That spectrum of trust, yeah, that's a smart design. I also noticed a mention of reasoning effort. What exactly is that? And why should we, as developers, care about this knob in our workflow?
Reasoning effort is essentially a knob you can turn to tell Codex how hard you want it to think about a problem. Think of it like allocating a thinking budget for the task. A lower effort setting means it'll return quickly for simple tasks, adding a comment, fixing a typo, a minor textual change. It's fast, but best for straightforward stuff. A higher effort setting, on the other hand, means it will spend more time reasoning through complex changes, maybe exploring alternatives, ensuring a deeper understanding before it proposes a solution. This makes it invaluable for those tricky multi-file edits, complex migrations across a codebase, or maybe those thorny bug hunts that require real architectural understanding. You're effectively telling it how much thinking time and compute to invest. This directly impacts the quality and comprehensiveness of its solution. It's like deciding if you need a quick glance or a deep architectural review from a colleague.
So it's like a thinking budget we allocate.
Yeah.
That's a fascinating design. Does setting that knob too low on a complex task ever lead to, more frustration? Like maybe it generates unhelpful solutions you then have to fix yourself.
That's a great question, and yes, it absolutely can. If you set the reasoning effort too low for a genuinely complex task, you might find Codex returning overly simplistic or even incorrect solutions. It's definitely a trade-off. You'd end up spending more time refining its output, which kind of defeats the purpose of the automation in the first place. The key is really to try and match the effort level to the complexity of the task at hand. For a brand new feature involving multiple files and new logic, giving it high effort upfront will likely save you more time in the long run than trying to force a quick, low-effort solution that just doesn't cut it. It's really about being a good manager to your AI teammate, understanding its capabilities, and setting it up for success.
That makes perfect sense. Okay, now moving from the terminal environment, how does that one brain extend its reach? How does it bring that same intelligence right into our coding environment with the IDE extension?
Right. The IDE extension is where Codex becomes truly embedded in your daily grind, your workflow. It brings the full power of the agent directly into your editor. It reads your selected files, or the file you have open, intelligently proposes edits as a preview, and then you apply them with just a simple click. When you have a file open, a simple prompt like, find the off by one error in paginate and fix the unit test for it is often enough context because it's acutely aware of the file you're actively viewing. It continuously tracks your working directory and, crucially, always shows you a diff before any changes land. This gives you that vital review step right within your familiar workflow.
That's fantastic for those in-the-moment edits. And can it reference other files in your project without you having to manually copy-paste paths or provide tons of context?
Yes, absolutely. This is a core part of its one-brain context awareness. You can direct it using powerful mentions, sort of like how you might mention a teammate in a document or issue tracker. For example, at serverroutes.ts to add a new route for resources built from at serverdataresources.ts. This helps ensure focused and repeatable results. It means it won't stray off task, and you get exactly what you asked for across different parts of your project, maintaining that seamless, high-context understanding. It's kind of like having a teammate who already knows the entire project structure and file layout by heart.
Okay, so we've seen the CLI for power user precision, the IDE for that integrated in-editor flow. When should a developer consider delegating a task up to the cloud agent and connecting their GitHub repo? When does it make sense to step away from the local machine?
Well, some tasks inherently benefit from more compute power, maybe greater isolation, or just a more hands-off approach. If you have a large multi-file refactor that might tie up your local machine for a while, or a complex migration, or something that needs to run a full, exhaustive test suite without impacting your local performance, that's a perfect candidate for sending it to the cloud. You connect your GitHub repo in the web interface, launch the task, and then you can literally walk away, grab a coffee, and watch its progress from anywhere. Once a change is ready, you'll see comprehensive diffs and a PR that you can review just like any human teammate's work. And what's truly compelling here, I think, is that Codex can also review your pull requests. It can act as a strong, unbiased first pass before human review. It can check for best practices, potential security vulnerabilities, performance bottlenecks, providing really valuable feedback right there in your PR workflow.
That's amazing, having it review your own PRs before anyone else sees them. Wow. Okay, given these powerful interconnected tools, CLI, IDE, clouds, how can a developer combine them? What's a seamless, productive daily rhythm look like? What does a multi-surface workflow look like in practice?
Yeah, many developers are finding success following a flexible but pretty powerful pattern. They might say, start by using the CLI to quickly spike a new feature branch and scaffold the initial structure for a new component. Get the bones in place fast. Then they'll probably switch over to the IDE extension to polish the implementation, tighten up typings, maybe adjust UX details directly within their familiar coding environment. Now, for larger or more independent tasks, like that comprehensive refactor we talked about, or maybe a new API endpoint that requires extensive testing, they'll delegate that to the cloud agent, let it run the exhaustive tests, and open a PR when it's ready. Then it just becomes this cycle of reviewing the proposed changes, iterating quickly based on feedback, either your own or from Codex, and finally merging. It's not about rigidly sticking to just one tool, but intelligently using the best interface for the job at hand, knowing it's all powered by that same underlying one brain.
Okay, here's where it gets really interesting, I think. It's a point the sources emphasize quite a bit. Repository hygiene. This sounds like more than just being neat. It feels almost like a strategic imperative now. Why is that so crucial for getting the absolute most out of Codex?
Yeah, if we connect this back to our core concept of the one brain, Codex truly thrives on clarity and predictability. It absolutely rewards structured and well-organized code bases with remarkable speed and accuracy. Think of it this way. Your repository becomes the instruction manual and the map for your AI teammate. The clearer the map, the better it performs. So key habits include things like naming your scripts consistently. For example, if you always use npm test or npm run lint, Codex can easily discover and execute those reliably. Keeping your modules small and cohesive helps the agent understand boundaries and responsibilities much better. Using an agents.md file, this is a neat idea, to document project conventions, like where do new features typically go, how are services run locally, it's like a readme specifically for your AI, and crucially, writing tests, good tests. Codex gets exponentially stronger and more reliable when it can run and trust your existing tests. It uses them as guardrails for its changes. It's basically like giving it a clear map, a set of instructions, and a way to verify its own work. That combination is powerful.
Yeah, that point about repository hygiene that really resonates. It almost feels like we're moving towards a world where a clean code base isn't just good human practice anymore, but it's actually a critical form of communication with our AI teammates. Let's try and bring this to life with a couple of real-world walkthroughs. How does this integrated system handle a common scenario, like, say, a bug fix?
Okay, let's imagine that paginate function we mentioned earlier is still a bit buggy. Maybe it has an off by one error on the very last page, a classic. In your IDE, you'd simply select the problematic function, or maybe the whole file, and ask the extension something like, find the off by one error in paginate and fix it. Also, write a new unit test to cover this specific edge case and update the existing snapshot. Codex would then analyze the code, propose a fix, generate that new test, and show you the diff all right there. You review it, apply the changes with a click, and run your tests locally. Now, if another edge case or maybe a regression pops up during that test run, you can immediately ask Codex to handle that specific input and update the tests again. It's all about brief, precisely scoped requests and these quick iterative feedback loops right within your editor.
That interactive iterative debugging sounds incredibly powerful. Okay, what about a new feature? Taking something from just an idea all the way to a pull request.
Right, for a new feature, you might start in the web interface with the cloud agent, especially if it involves multiple parts. You connect your repository and initiate a task, maybe something like add a health endpoint to the main API, wire it to the router, make sure it returns status, okay, and also add a simple check to the CI pipeline to ensure this endpoint is always available after deployment. You then watch the logs as Codex works through the problem. It might create new files, modify existing ones, update your CI configuration. When it's done, you'll get a notification. You can then review the detailed diffs right there in the web UI and open a PR directly from the interface. And as we discussed earlier, you can even take it that one step further and ask Codex to review that PR itself. Maybe ask it to focus specifically on security best practices or potential performance issues. Get that initial automated pass before your human teammates even need to look at it. It covers the full life cycle, really, from concept to a reviewed PR, all within that one brain ecosystem.
Okay, for you, the listener, who might be using other coding assistants already, how does OpenAI Codex truly compare to something like, say, Claude Code? Both are obviously powerful, but what's the pragmatic distinction? Where do they differ?
That's a crucial comparison, yeah, because both are definitely capable of building real software. But they often cater to slightly different priorities or maybe preferred workflows. OpenAI Codex, from what the sources suggest, offers a very tight multi-surface workflow. That consistency and context awareness across the CLI, IDE, and web is paramount. It seems known for its extremely consistent instruction following, handles large refactors particularly well with its high reasoning capabilities, provides those first-class PR review features directly, and it's deeply linked into your existing ChatGPT plans. Claude Code, on the other hand, also has strong editor and CLI experiences. It can sometimes be a bit more verbose in its responses, which actually some developers prefer for clarity. It might require a bit more guidance, perhaps, for those truly massive cross-module refactors compared to Codex's high reasoning mode. It also offers good review capabilities, often through its plugin ecosystem, and it boasts a pretty broad model choice ecosystem, giving you flexibility in the underlying large language model you use.
So, digging a bit deeper than just the feature checklist, is there a fundamental design philosophy that seems to set these two apart? Maybe one prioritizes speed while the other focuses more on deep context. How might that influence a team's decision if they're building, say, a brand new greenfield project versus maintaining a large, complex legacy system?
That's a really insightful question. It does feel like Codex is designed around a philosophy of integrated and persistent context. It aims to be that single, omnipresent, brain-carrying state and understanding across all environments. It optimizes for a deeply integrated developer workflow and tackling those complex, multi-step tasks. Claude, while also highly capable, often seems to emphasize a more conversational and adaptable interaction style. It allows for more expansive dialogue, maybe bringing in external tooling through its plugin ecosystem more readily. So for a greenfield project, maybe Codex's holistic, integrated approach could lead to incredibly fast initial scaffolding and ensure consistency from the start. But for a large, entrenched legacy system, one with unique quirks and maybe less clear structure, Claude's more verbose, adaptable conversational style, combined with its plugin ecosystem, might allow for more nuanced exploratory interactions. Especially when the map, as we called it, isn't as clear. It could help document and refactor incrementally in those trickier situations. The choice really comes down to which design philosophy aligns best with your project's specific challenges and, frankly, your team's preferred way of working.
That's a fantastic distinction. Okay, so pulling it all together, what's the overarching mindset? What's the mental model for you, the developer, to be most productive with Codex? It's clearly not just about using the tool itself, is it?
You're absolutely right. It isn't just about the tool. It's profoundly about how you interact with it. The overarching mindset, I'd say, is to treat Codex like a smart, highly capable teammate who really thrives on clarity and well-defined tasks. You almost need to be a good manager for it. Tell it exactly what success looks like for any given task. Show it where your scripts live, make things discoverable, give it a clear, structured plan for large changes, maybe breaking them down into smaller, digestible steps if needed. And critically, always ask it to check itself with your existing tests. Leverage those tests. Keep your edits highly scoped and iterate quickly. Don't try to boil the ocean with one massive prompt. Think of it more like a dialogue, not a monologue you're dictating.
And what's the long-term benefit of adopting that approach? Maybe even a surprising benefit, beyond just the immediate productivity gains.
Well, you'll likely notice something quite profound after a few days or weeks of working this way. Your code base just inherently gets cleaner. Your scripts get sharper, more discoverable. And the agent itself actually gets faster and more accurate over time because your repository literally starts to read like a map to it. This isn't some accidental side effect. It feels like the compounding result of steady, thoughtful habits in how you structure your projects and, critically, how you communicate with your AI partner. You're not just coding. You're kind of training your entire environment to be more efficient for both humans and AI.
We've covered a lot today. We've seen how Openai Codex offers some really significant leverage, integrating pretty seamlessly across your terminal, your IDE, and the cloud, helping you move past maybe the dull parts of coding to focus on the ideas that truly matter, the creative problem-solving you enjoy.
Exactly. It's not about ceremony or adopting every new shiny object just because it's new. It's fundamentally about pure, unadulterated productivity, getting stuff done faster and better. The sources really strongly encourage you, start today, not tomorrow. Install the CLI, add the IDE extension, connect even just a small personal repository, and complete just one small task, just one. Get that initial momentum going and feel the shift for yourself.
So after this deep dive, thinking about everything we've discussed, what does all this mean for you, the developer listening, and maybe the future of coding itself?
Yeah, this raises an important, maybe even a slightly philosophical question, doesn't it? As these AI coding agents like Codex become increasingly sophisticated and deeply integrated into our daily workflows, does something like code clarity or repository hygiene shift? Does it move from just being, a good human practice for maintainability to becoming a critical, explicit form of communication with your AI teammates? Is a clean, well-structured code base now, perhaps for the very first time, explicitly a strategic asset for effective AI collaboration? Does it allow your intelligent partners to perform at their absolute peak? Definitely something to mull over as you begin your own journey with Codex.